In this video I'm going to show you how to store data in flash memory and also versus storing it in RAM memory, and this is for the AtMega328P. So if I go to, in a previous video I have actually stopped here, and what we saw there is that you can also access flash. Now if you want to access your flash, that means you can also store data in your flash memory and actually collect it then from flash memory, because normally especially in the AtMega328P you've got 32K memory in flash, and if you've got quite a large array that you want to store data in, it can take up quite a lot of space in your RAM memory, which is not that big. I think it's around about 2K. So it is one solution is to actually store it in your flash memory or program memory. So what you need to do is you have to include this the header file pgm space. You have to include that, and you have to define your array, for instance, by putting here const, and then you also make use of the name progmem, and then you give the name of your lookup table or your array, and yeah, then it will store these values that you see here. It will be stored in your program memory, and it will take space in your program memory and not take space in your RAM memory. So I'll show that to you now in my program that I've written for the Atmel Studio, in Atmel Studio. But you will also, if you're making use of this header file, then how do you read from this array of yours? You basically just call this function pgm read byte, pgm underscore read underscore byte, and you say you specify go to the address of the lookup in this specific lookup array, and yes, you will then basically, in this specific case, I will be, because of the startup, I will be a 0, and it will actually collect this value, which is a 5, and store that into the variable by the name of array. But let's go and look at the program that I've written. What I've done again is I've used the previous, let me just stop this thing. I've used the previous Proteus design for the AtMega328P, and I've connected these two displays through binary to BCD decoders to port D. So what I'm going to do is I'm going to basically just count from 0 to around about 19, I think it is. But what I've done is, let's go to the program to give you a better idea, is yeah, let's just see what I've done. First of all, again, you have to include always the IO header file. In my case, I'm also going to make use again of internal software delays. So I have to specify the frequency. In my case, I'm making use of the Arduino Uno board, so the crystal on there is 16 megahertz. I have to define the delay then in order to make use of the delay functions, and this is where I've said let's include then pgm program space header file. And again, in one of my previous videos I have shown basically how you can take a display value and convert a display value or a value, any variable, into a low and a high byte, which you combine at some point. Here it is combined, and the purpose of that is basically to change it from a binary value to two BCD values, combine them, and then display them on a 2 7-segment displays. So this is just an old program that I've used here, but this combines two values, or well, basically two BCD values for display on port D quite effectively. So in my program, just like we've seen before, what I've done here is I've also used const unsigned char program progmem for program memory, and I've called this array 1. And as you'll see here, what I've done here is I've just used even numbers here from 0 up to 18. That is sitting in the flash memory. In other words, this array, or this array has now been stored, will be stored in the program memory, in your flash memory. Whereas this one, is going to be stored in your RAM memory. In array 2, it's just normal, straightforward, unsigned char. It's called array 2, so it's a different array from that one, which is stored in flash memory. So this one is stored in the RAM memory, and here I've basically used uneven numbers from 1 to 19. So in my program, all I've done there is basically I've declared, again, I've made port D an output by making all the pins 1s on DDR D register, and then I've said let's count from 0 basically to 9 because it's smaller than 10. There are 10 in this array here. You've got 10 values. In this array we've also got 10 values, so it's from 0 to 9 which it will count. And just like before, if you can just quickly look back here, just like before, if I want to read that value, this is the way it should be done. Read from the program memory. This is how it's done. So what I've done here is I've declared J as a variable, and I'm using this function to get whatever is specified from I. In the first instance, it will actually go and get from array 1, it will get the value of, well, I is 0, but in array 1 the first element is 0, so it will go and collect 0 from the program memory, and then it will basically display it on port D after calling the function that I've just shown, how to convert binary to BCD. And this is the value that I will be displaying at the end of the day. So I could have put this section here, the whole of that section, I could have put it in here, and it also works. But yes, it's first going to get the 0 from the program memory and display 0, and then it will go to array number 2, again the first element, which is element 0. It will then go to this one, then it will display a 1, and then I will change. Only then will I change. I is first a 0, so it's going to be a 0 here, collecting the value of 0 and displaying 0. This is then still a 0, but now it's collecting the value of 1 from the RAM memory and displaying the 1. If I changes to a 1 after incrementing here, it's going to display a 2, and this one will display 3, etc. So this is just to show you this section of the program actually collects the data from my program memory. So it's using the program memory space, of which I have got quite a lot. It's not a disadvantage, but you must remember that you cannot change this array that we've specified here in program memory. Cannot be changed. That's not possible. It has to be, it remains as it is there. But normally, once you've got an array, these values are fixed inside your array, or it could be, in this case it's numbers, but it could be text also. It doesn't matter what it is. It's normally fixed. So it's a nice way of making sure that you do not waste space by making use of RAM memory and only making use of partially making use of program memory space. So if I can just build this, if I build this and I go to my Proteus design, which I've got here, I've already preloaded this thing, and you'll see then it counts from 0, 1, 2, 3, 4, etc. And this thing will count up to 19 and then go back again to start counting from 0. So the operation is perfect. As you can see, or what we've seen, in other words, the even numbers is coming from program memory and the odd numbers is coming from RAM memory. I could have, of course, done this whole thing only from program memory. I just wanted to show you I can get it from both, but for this specific case, a better example would be to put everything in program memory, because then I do not waste any space in the RAM memory. And this is how you do program memory, use program memory space as an alternative to use a RAM memory space. Thank you.